So today's lab is one of my favorites of the whole semester because it sort of combines a really elegantly designed interface device with a very simple interfacing solution. So when we talk about joysticks, of course, you're familiar with joysticks from video games, but joysticks are actually used a lot in industrial applications for robotics. They're, of course, used as part of flying an airplane. Joysticks can provide very complex information in a very intuitive manner that can be very easily interpreted by the computer. So joysticks are actually a really good control system. Here we see a 2-axis joystick, the kind that we're going to be using in lab. It can rotate forward and backward, which we'll call up-down, and then it can also rotate left and right, and we'll call that left-right, or vertical and horizontal. And in each case, as it's rotating, it's actually attached to a little potentiometer down here. Remember that when a potentiometer changes, its resistance changes, and so we can, as we did, in fact, just in the most recent lab, we can see that if we have a potentiometer, we can adjust the voltage, and if we send that into an A to D converter, into an analog input, we can then convert that into a digital number between 0 and, say, 1023. So here you can see that we're going to attach the 2-axis joystick to +5 volts and to ground, and we're going to send these two signals into 2 of the analog inputs on our Arduino microcontroller. So the hardware connection is actually pretty simple. The power and ground is already made for you. You just need to connect one of them to analog input 0 and the other one to analog input 1. You want to connect the grounds and the +5 volts. And then we're going to actually, I'll show you this picture, we're going to actually be sensing the state of the joystick using 4 LEDs. I'm going to refer to this one as the top LED. Over here, this one will be the right LED. This one will be the bottom LED, and this one will be the left LED. And you can see here that I tell you which pin each one of those should be connected to. Now, as soon as you've made those connections, I want you to ignore the names that were used there, because you might not be able to see this, but the joystick had to be rotated 90 degrees clockwise to put it onto the breadboard. If I hadn't rotated it, it wouldn't have fit properly. So my advice would be to actually now rotate the entire Arduino system so that the joystick is on the bottom and the 4 LEDs are on the top. So when you do that, then this LED will be the top LED, this one will be the left, this one will be the bottom, and this one will be the right. And this will be the vertical axis, and this will be the horizontal axis. That really totally makes sense if you rotate the board, but if you don't, then it's going to be difficult to sort of consider how it's going to work well with the code, because the code is going to assume that you've rotated the board. Okay, so let's look at the software. We're going to have vertical input is going to be on channel 0, pin A0, and I'm going to have an up output, and that's going to be pin 12. So that's going to be the LED that's going to light as anytime that we think that the joystick is pointing up. I'm going to have a global variable that's going to be called vertical value. Inside of setup, I'm going to set the up output to be an output, and I'm going to set it to initially be turned off. And then inside of loop, vertical value, which we previously defined to be an integer, is going to be set by this analog read function. Remember that analog read is going to take the contents of the A to D converter, and it's going to send it into that particular value. So we're going to read off of pin A0, vertical input. We're going to do an analog read, convert it to a digital value, and then we're going to put that into vertical value. Now we know that that number can range between 0 and 1023. It'll probably be around about 500 or so when it's in its neutral position, but if we push it quote-unquote up, then that will increase the number. And so if it gets above, say, 800, then we're going to say, okay, now it is pushed up, so we're going to turn on the up LED. So in that case, we would put that to be high. Otherwise, if it's not greater than 800, we say it's not up, and therefore we would put it to be low. And we're going to do this every 10 milliseconds. And that's it. If you do that, then the code will correctly turn one LED on and off, depending on whether or not you're currently pushing the joystick into the up position. So next you're going to modify that so it'll also include the down position, and so you can push it away. If it's greater than 800, it'll turn on the up. If it's less than 200, then it'll turn on the down. And so you will have then established a 1-axis joystick. And then you ready to demonstrate that? Then we're going to go to a 2-axis joystick. So now we're going to have a vertical input and a horizontal input, and we're going to have 4 outputs, down, up, left, and right. And then you're also going to need a new global variable, horizontal value, that'll go right alongside with the vertical value. Define all 4 of the outputs to be outputs, and then set them all to low. And then in loop, add a second analog read so that you can read the horizontal value as well. And then you're also going to need to add 2 more if then else blocks, just like the 2 that are already there, the one that I originally wrote and one that you added. And now you're going to add 2 more to read when it goes left and when it goes right. And then when that's fully functional, you can demonstrate that to your professor or teaching assistant. Then what we want to do now is we want to do a better job, because right now we can read all 4 values. We can see when it's up, down, left, and right, but it's not great because we've done 2 things. First of all, we've hard-coded this 800 and 200, and those are pretty high and pretty low values. You actually have to have quite a lot of travel in the joystick before you turn the light on and off, or before you turn the light on. We'd like it to be a little bit more responsive. The problem is that, remember how I said that it would be close to 500? It's actually not that close. It's actually, in the real world, this joystick is going to be delivering values that are not right at 512. So what you need to do is use the serial monitor to detect what is that standard value, and then see what, does it go all the way down to 0? Does it go all the way up to 1023? I just want you to sort of investigate what's going on with the actual values that are coming from the joystick, because what you're going to find is that this is not an ideal world. This is not a place where the joystick is going to be absolutely behaving the way that we think that it should. So knowing that the joystick is not ideal, and also kind of brings into question this 200 and 800, and we'd like the joystick to be more responsive, so we're going to calibrate the joystick. Calibrating it simply means we're going to read what the neutral value is. What's the value when it's spring-loaded back to the center position. We're going to read that right when the program begins, and then we're just simply going to look for changes away from that neutral value. So you want to add these 2 lines to setup. We're going to have 2 new global variables, horizontal center and vertical center. And in both cases, we're just simply going to read the current input for both of those in setup. That's only going to happen once, right at the beginning. And so we're just going to read what is the center value. From your time with the serial monitor, you should see that the center value is pretty standard. It's really not going to move. So we're going to have these 2 new global variables, horizontal center and vertical center. We're going to initialize them with what is the neutral value, the center value, around 500, give or take about 50. But then all we need to do now is check not are we greater than 800 or less than 200, but are we greater than horizontal center or less than horizontal center? Are we greater than vertical center or less than vertical center? That's going to allow us to be able to respond very quickly to even the smallest change in the joystick. Now, I should mention that I was a little bit disappointed at how much quote-unquote play there is in these joysticks, that they can move, several degrees before you actually begin to see any difference in the voltage. So just be aware that these joysticks cost about $10 a piece. If you're designing a fancy airplane or something, you're going to have $1,000 joysticks, and those are going to have a lot less play and a lot more precision to them. So you've now you've modified the code so it's calibrated. You're going to be looking for changes away from the center value. The last thing we're going to do is add a dead zone. So we're going to simply say maybe we don't want to respond immediately and turn on the LED the second that we're greater than or less than the center value. So we're going to say you have to get at least 10 units away. Now on a range from 0 to about 1,000, that's only about a 1% difference. And you might find different value of dead zone that might work better. Maybe your dead zone will be 50 or 100, but 10 is a pretty reasonable place to start. And then you're going to change only the if statements. So instead of saying if vertical value is greater than vertical center, now we have to go a little bit past vertical center. We have to go greater than vertical center plus dead zone. Or if horizontal value is less than, not just horizontal center, but less than horizontal center minus the dead zone. So we have to go further to the left and further to the right, further up and further down to get away from that horizontal and vertical center value. If we do that, then we're going to be able to turn the LED on. We'll have a calibrated joystick with a dead zone, which is pretty much everything that you'd want it to be. So once you get that one done, I think that you will have accomplished quite a lot this week. You'll notice that I didn't give you most of the code. I'm sort of transitioning to where you'll write more and more of the code. Actually, you probably wrote more than 3/4 of the code for this one pretty much on your own, with some input from me, of course. But this is a lab that you're going to be doing an awful lot more code writing than in previous labs.